So what is the last topic?
Line integral, sir.
Line integrals. So homework ఏమైనా ఇచ్చానా?
Yes, sir.
స్క్రీన్ ఓకేనా అండి?
Okay, sir.
Line integrals. Okay, so before going to the next topic, so first of all we'll review the previous class. So in the previous class we have seen line integrals. So what is the definition of the line integrals? Any integral which is to be evaluated along a curve is called as line integral. So here f is a vector point function. Assume f is equal to f1i plus f2j plus f3k, and r is the position vector at the point xyz, and c be a curve from the a to b. Then the line integral is integral a to b, the dot product of f and dr. Okay, or integral a to b f1 dx plus f2 dy plus f3 dz. So this is the line integral definition. And the first example is, suppose here f is a vector point function. F is equal 3xyi minus y square j. Then evaluate integral f dot dr, where c is given by the path y is equal to 2x square from the point 0 0 to 1 comma 2. So in this one, so the given curve is y is equal to x square. So y is equal to 2x square. So first of all draw the diagram. So in this diagram it is the parabolic structure. So here you have to take this path only. So 0 0 to 1 comma 2, this is the path, and the r is the position vector. That means r is equal, here we have to take xi plus yj plus zk, and dr is equal to dxi plus dyj plus dzk. The given question is integral. So f dot dr is equal the dot product of these two vectors. So already this is the f vector and this is the dr. So after solving, here we will get the integral 3xy dx minus y square dy. So this is the line integral. That means the only single integral, but we want to solve the problem. For that you have to change the total in terms of either in terms of x variable or y variable. How can you modify? So it has given some curve. The curve is y is equal to x square. So based on this curve, just you have to convert into either y variable or x variable. But in this problem we are converting into the y variable. That means y is equal, in place of y I am taking the 2x square. In place of dy I am writing the 2 into 2x dx, and the limits you have to take the integral 0 to 1. So just substitute. After substituting, so this is the now the total in terms of x variable. Just to do the normal integration, we will get the minus 7 by 6. So this is the first question. Similarly, what is the second question? So second question also same. So evaluate the line integral f dot dr, and f is, it is given that x square y plus x square y square I plus y j, and the curve is y square is equal to 4x. So it is also a parabola, but the parabola is like this. In this parabola you have to evaluate from 0 0 to 4 4. So in this direction same. So do the dot product of these two vectors, we will get the integral c x square y square dx plus y dy. So here also same, just to change the total in terms of either variable x or variable y. So anyway here also I am taking the total in terms of variable x only. That means substitute y square is equal to 4x, and y dy is equal to substitute 2x 2 dx, and x limits are 0 to 4. So now this one is the integral 0 to, after converting in terms of total x, we will get the result integral 0 to 4x cube plus 2 into dx. Just do the normal integration. After doing the normal integration, we will get the result is 264 is the result. So this is the second problem. In the first and second problem they have given only parabola. So in the third problem they have given the square. So square is here the plus or minus 1 and plus or minus, x is equal to plus or minus 1 and y is equal to plus or minus 1. That means x is equal to 1 and x is equal to minus 1, vertical line, and the y is equal 1 and y is equal minus 1 is the horizontal line. Just from these 4 lines, just it is formed a square. So here, according to the previous one, just we have the only one path, but here this path we have to divide into 4 paths: c1, c2, c3, c4. So first of all, we have to solve the c1 path. That means in this one we have to assume x is equal to 1 and y values are minus 1 to plus 1. Next one, c2 path. In the c2 path we have to take y is equal to 1 and x values are from 1 to minus 1. Similarly, c3 path. So we have to take x is equal to minus 1 and y values are running from 1 to minus 1. And c4 path. In the c4 path we have to take y is equal to minus 1 and x values are running from minus 1 to plus 1. Okay. So do the just separately c1 path for c2 path, c3 path and c4 path. So this is the first one, c1 path. So in the c1 path, so it is the vertical. So x is equal to 1 and y running from minus 1 to plus 1. Now dx is equal to 0. Now after doing the normal integration, we will get the 8 by 3. Similarly, c2 path. In the c2 path, so it is the horizontal line and y is fixed value, y is equal to 1 and x is running from 1 to minus 1. So a dy is 0. After converting in terms of only x, here we will get the result minus 2 by 3. So it is the c2 path case. Similarly, c3 path case. So x is fixed, that means x is equal to minus 1 and y is running from 1 to minus 1. So after substituting, this is total in terms of y function and the result is minus 8 by 3. Next one, c4 path, same. In the c4 path, so x is fixed, so y is fixed and x is running from minus 1 to plus 1. The result is 2 by 3. So now this is the 4 results. These 4 results substitute in the equation star. 8 by 3 minus 2 by 3 minus 8 by 3 plus 2 by 3, you will get the 0. So the line integral of this problem is totally 0. Okay, so this is the third problem. And fourth problem, I have given homework. So a vector field is given by f is equal to sin I plus x into 1 plus cos y j, and the circular path x square plus y square is equal to a square and z is equal to 1, and the result it is pi a square. Okay, ఎంతమంది సాల్వ్ చేస్తారండి ఈ క్వశ్చన్ని? సాల్వ్ చేశారా? ఓకే, గుడ్. నెక్స్ట్ వన్
సార్, ఈ ప్రాబ్లం చెప్తారా సార్?
ఏదండి? ఇదా అండి?
ఫస్ట్ది సార్.
ఓకే, వెరీ గుడ్. నెక్స్ట్ సెకండ్ ప్రాబ్లం వచ్చిందా?
వచ్చింది సార్.
ఓకే, ఫస్ట్ ప్రాబ్లం డౌటా? సెకండ్ ప్రాబ్లం ఏం డౌట్ లేదు. ఓకే, నెక్స్ట్ ఇది థర్డ్ ప్రాబ్లం
వచ్చింది సార్.
ఓకే, ఫోర్త్ వన్
వచ్చింది సార్.
ఫిఫ్త్ వన్
వచ్చింది సార్.
వాట్ ఈస్ ద ఫిఫ్త్ రిజల్ట్?
5 సార్.
5. 5 is the fifth result. 5 pi. Pi is the result. Okay. Pi is the result. Okay. ఎవరైనా సాల్వ్ చేశారా అండి ఫస్ట్ హోంవర్క్ ప్రాబ్లమ్? నోబడీ? ఫస్ట్ ప్రాబ్లం ఎవరు సాల్వ్ చేయలేదు? హలో, ఇస్ ఆడబుల్?
ఎస్ సార్, ఆడిబుల్ సార్.
ఫస్ట్ ప్రాబ్లం ఏమైనా సాల్వ్ చేశారా అంటున్నా, అదర్ దాన్ సిఆర్స్? త్వరగా చెప్పాలండి. ఓకే, సాల్వ్ చేయాలా మళ్ళీ ట్రై చేస్తారా?
సాల్వ్ చేయండి సార్.
ఓకే, but anyway this line integral problems, I think in the previous class we have seen I think 8 problems. So those 8 problems we will solve by using the Green's theorem also. Okay, so by using the Green's theorem, this 5 problems are very simple. Okay, now anyway we will solve the problem. తీసేస్తున్నాను ఒక్క నిమిషం. Now a vector field is given by f is equal sin y plus x into 1 plus cos y I, and the circular path, what is the circular path? X square plus y square is equal to a square and z is equal to 0, and the result is z is equal now what is the line integral here? Integral c f dot dr is equal whole integration of c sin y I plus x into 1 plus cos y into j into dxi plus dyj plus dzk. It is equal whole integration of sin y dx plus x into 1 plus cos y into dy, the rest of 0. Okay, now in the previous problems that is very simple, but how can you solve here? And what is the path here? The given path is x square plus y square is equal to a square, and the z value 0, so here there is no z. Or you can take, suppose x is equal to under root of a square minus y square. You can easily convert into in terms of y by taking y is equal to under root of a square minus x square. We can easily convert into in terms of x. Which one is the best, or is there any alternative approach is there for solving this problem? ఏమైనా ఉన్నాయండి? Anybody? Hello? సిఆర్స్ తొందరగా ఏదో ఒక రెస్పాన్స్ ఇవ్వండి.
I don't know, sir.
ఐడియా ఏం లేదు. మై గాడ్, నో ఐడియా. Very good. So by converting into polar form, this problem is very simple. Okay. So suppose if the problem related to circle, just to convert into the polar form, that is very simple approach. Just better to convert into the differential, sorry, the integration in terms of polar. Okay, that is the main idea. Okay, now we will so just convert into polar. Okay, now the total problem we are converting into the polar now is equal integral sine y dx plus x into 1 plus cos y into dy, and so it is the y axis, it is the x axis, and what is our circle? This is the circle. So in the circle, just equation x square plus y square is equal to a square. That means you have to take the total path. Total path. So by converting in terms of polar, x is equal to I am taking a sin theta or cos theta.
Cos theta.
X is equal to a
Cos theta, sir.
cos theta. Very good. And y is equal to a sin theta. And what is the dy value? Dy value is a into
Cos theta d theta.
cos theta d theta. Very good. Dy a cos theta d theta, and dx minus a into sin theta d theta. Okay, that means the total problem just we can easily convert in terms of theta. And what is the theta limits? So it is the total circle. So circle means you have to take the theta value is total. So 0 to 2 pi. Very good. So 0 to 2 pi. ఇప్పుడు సాల్వ్ చేయొచ్చండి ఈజీగా. నౌ ద ప్రాబ్లమ్ నౌ సింపుల్. సో ఇంటిగ్రల్ 0 to 2 pi and sin y. So before going to solve the problem, just a small modification. Now integral sin y dx plus x into cos y dy plus x into dy. Now according to the inspection method, this sin y into dx plus x into cos y dy. So we can club these two. So integral sin y, okay, ఇక్కడ రాసేద్దాం, సపరేట్ రాస్తున్నాను. So sin y dx plus x into cos y dy. So this whole part I can write x into derivative of sin y, and here the sin y dx. By using the product rule, we can write derivative of x into sin y only. That means this whole part, this whole we can write, this one we can write derivative of x into sin y, x into sin y plus integration x into dy. Now according to the previous one, integration of dx, what is the integration of dx result? What is the integration of dx result? Integration of dx, only x. Same concept here. What is the integration of this one? Integration of this one is x into sin y only plus, so it is the the different symbol, so integration x into dy. Now so it is the without limits. Now I am taking the with limits. With limits means just to convert into now the polar. The problem now became simple. Now come to the polar form. Already we know that what is the x value? A cos theta and sine into y value, sine of a sine theta, and the limits from 0 to 2 pi, plus now the second integration up to now we are not evaluated. Now integral 0 to 2 pi, x value is a cos theta and dy value is a cos theta into d theta. So okay, first one leave it. Now the come to the second one. So here this one is the a square integral 0 to 2 pi and cos square theta. So integration of cos square theta, so we can easily solve in the many ways by using the reduction formulas or by using the cos square theta. But here I am using the cos square theta result. So in cos square theta is equal, we can write 1 plus cos of 2 theta by 2. Now integration of 1 is theta and integration of cos. What is integration of cos? 2 theta by 2 only integral. So limits from 0 to 2 pi. So this is the second integration result. But already first integration we know that. So cos theta sine of 0 sine 2 theta. Limits 0 to 2 pi. Now so a cos theta sine of a sine theta 0 to 2 pi. A cos theta sine of a sine theta 0 to 2 pi. Now apply the limits. Now after applying the limits, upper limit is 2 pi. So cos, what is the upper limit result? 0. Is it 0? Because here there is a sine of 2 pi. So it is entirely 0 for upper limit and lower limit. So sine 0 0, so it's 0. This means the first integration result 0, second integration. So theta is 2 pi, so 2 pi and the cos of 2 pi it is 0 minus 0 plus 0. So the result here 2 pi into a square by 2. So pi a square is the result. Okay, clear Andy?
Yes, sir.
Okay. So anyway, this problem we will solve again by using the Green's theorem. Okay, I think in the next class we will solve this line integral problems by using the Green's theorem. Okay, but this is the normal approach, but by using the Green's theorem, so these problems are very simple. Okay, now any other doubts from the previous class? ఉన్నాయండి? No more? త్వరగా